Good morning, folks. Ooh, this is exciting. Hmm. It appears we have some results. Hello, Pepe. Hello, Muffin. This is very good. Look at this. We have a couple of these runs that are reaching 32K in 1 gig, though none of them reaching 65K. We'll have to look at that. Yeah, this one right here. Let's look at something real quick. So, if I do, is this 7 mil or 700K? They're quite slow. Let's put this on merge score. And we gotta get the correct metrics out here. Okay, no, score is very nicely correlated, right? So now all we have is we've got time in minutes. 6 minutes. What's in the box, guys? Why is Puffer so niche and underrated? Industry experts know, normies don't. Because it's like the RL people on language models are doing stupid baby mode RL. Like, there's real work to be done in language models, but it's not really anything to do with RL. They have the dumbest, simplest, easiest possible form of RL, and they have a really dumb setting for it. Okay, we got to copy these. Oops. I wonder if we have all the experiments done yet. We probably don't, huh? Yeah, this thing is still going. It definitely needs a big hidden size, though. Look at this. It's actually gone and gotten itself 512 hidden dim. And a num layers equals 5. RNN args I don't believe are being used anymore. And then we do vec num threads equals num buffers is actually set to 1 in this. 16K agents. And then we've got a new beta 1 value, slightly lower. we've got a slightly lower beta 2 value. Clip coef is much higher. This is actually a much healthier. Oh no, actually, never mind. That's a very aggressive clip coef. Not much healthier. This is normal range entropy. This is EPS. Small EPS, that's fine. Lambda is very small. It's kind of weird that we're seeing these like very small lambdas and these very high gammas. Interesting. Oh, actually, I think I know what that means. That's funny. And then learning rate is, this is the main one. 0.002, so small learning rate. Higher max, oops, slightly higher max grad norm. And mini batch size is the same. Alpha and beta. Oh, we actually have a replay ratio on this one. It's actually very nice that we have this parameter in there. We have our VF clip coef. We're not going to have to do this stuff manually for much longer because Constellation has a feature where you can just click to copy everything. But it's not fully working yet. Okay, and that's all the parameters, right? That should be all of the parameters. How many experiments total do we have? Only 287 experiments, actually. Oh, you know why? We have it capped to 1 billion steps in sweeps. So this is probably, yeah, you see this is out at 800 mil already. So that's got to be why. Okay, I think that this is enough for this sweep, though. Whoops. This will be good for us to try out our new bindings as well. And that's still pretty quick. 2.2 million steps per second for 3.9 mil per am. Oh, I didn't check num layers, though. Yes, I did. It was 5. We're good. We are good. Hey, 24. Okay, we did mess up the total time steps here. So it's 730 mil. Why don't I just put this in? And just set it like this. You dummy, you just did the wrong end. What am I planning today? I'm going to be cleaning up as much of PufferLib as possible today. I want to start getting us close to a release build. I think in practice, it's like these always take forever towards the end, so it's going to probably be another couple months. There are some bugs. There's some small missing bits. There's a bunch of stuff I'm not super happy with the way it's done right now. And we also are not releasing before we have 100,000 experiments worth of data across all ends with good sweeps, plus blog posts, plus other stuff. But we're going to end up having something pretty stable, I would hope, towards the end of today. You can all watch this run. This score right here is the score in 2048, so you'll see this be superhuman very quickly, or super at least better than you are. Give me 1 second to grab something. Good morning. Actually, let's send this to Kyung. Was Anthropic done differently? What do you mean, what have they done differently? Nothing. You flooded the internet with shitty ads. Go see our latest run. We're gonna do like this one. Oops. Yeah, look at this. Here's our new run. How was PyTorch? What do you mean? We're gonna let this finish, just so that we have this benchmark. We're gonna commit these nice new params up. I'm gonna make one other small change. And then we're gonna start on the major refactors for the day. But this is a very nice result to have overnight. Take a look at this. This rocks. I mean, we can pretty well see if we just put it on this mode. Like, was it? This is 17K. Well, you can't fully see actually that more compute equals more performance yet because it's capped on steps. So we will fix that. And this is like super solid result. This is not even with the custom network, by the way. This is... I think I kept their... Did I keep their encoder at all? I think I did keep the encoder. We're gonna go check. I'm pretty sure I kept just the encoder. I did. Pretty good. Okay. Let's add the new config in. Whoops. I don't think we had that in I don't think we had that result so quickly before. This is nice. Now we can start on the real work for the day. Let's come up with the plan. So we cut out all of the very easy to delete code last night, and we made one major enhancement. We actually solved both of these. So like remaining refactor. I just want to figure out like where the complexity remaining is. I think I can do this from here. I think it's going to be like, let's move ocean. Let's start on this. I actually really don't know what we're going to do specifically on cleanup until I get more into it. And now I'm looking at it. We got a lot of stuff cleaned up yesterday. I think that the safest initial bet, though, is... And actually, here, we'll just... One real quick. Whoops. So I don't need this. This is a super simple... I'm allowed to do that, right? That should be like several hundred lines from model C++ into ocean specific code. We'll also move the dispatch over. And what will the remaining complexity be after that, I wonder? Muon for sure. Muon gets cleaned up. That mock just goes away, so that file's gone. Squared CU goes away if we're not going to have that. Advantage stays for now. And then realistically, there's just some small cleanup in models, followed by, I think the main bulk of the rest of it's just going to be in PufferLib C++, right? Like there's a little bit to do in modules, but I think then the most of the cleanup is just going to be PufferLib C++. And that's not even super messy as much as like there's some stuff that's in there that needs to be elsewhere. And there are a bunch of the functions that we've graphed that are a bit confusing, and there are a few redundant bindings. So I don't even think that's going to be that hard. Like, we actually, now that we fixed the main bfloat jank thing, that was actually the main complexity, believe it or not. Like, most of the bloat of the library was there. Now, there's some numerics crap where, like, the kernels are a mess. So we probably want to clean up our kernels. Have you noticed a difference? No. Honorary, I don't want these, I don't want to, like, be more and more reliant on the models being smarter. Look what I just had it do. I literally just used it to copy some code around. Like, that's it. It literally just, it's not writing any new code here. I just used this to move some code around to some new files. Because I figured it would also get the includes. Like, realistically, if this were C, I wouldn't have even done that, right? Because, like, I just don't know what the hell the includes are with Torch and CUDA. I would have just copy pasted it myself. And actually, this is taking too long to have even been worth it, frankly. Though I did get a couple minutes to sort of think about the rest of this in the meantime. We definitely have some bloated kernel logic. And kernels we really, really want to be clean. I think this is the most valuable piece of code, ultimately, that we'll have in Puffer. We'd like the graph tracing thing to be relatively clean as well. And then there are a few other things that are relatively easy compared to those. I think those are the two big ones. Yeah, so these just get moved. I wonder if it deleted my comments. That'd be hilarious if I go and I look and it's like deleted all my comments. It would just delete Claude. Okay, this time it didn't. So this is 440 lines. And actually, it's going to be more because this is now going to come out of, so look at this from before. Okay. And now we've taken like 300 lines out of models. So this is now a reasonable, oops. Yeah, this is now going to be a reasonable enough amount of code. We've got Ocean, which is now 440 lines. Yeah, and then we have modules is 593 lines, up from, it's actually, oh no, it's less. Okay, so models back to 7.7. Okay, that's good. But that's a reasonable amount of code. Yeah, and then this no longer needs these jank headers because it's just directly in the CU. So that's actually going to make it shorter. Cool. I'm going to use the restroom. I need a few minutes. And then I think we'll start on either the policies or PufferLib, C++, one of those. I'll be back. All right. Well, that's nice and fast, yeah? Same speed as before, right? 14 plus? Very good. Very, very good. $670-ish lines. Let's take this one. So we're not even sure if we're going to keep this one here at all. Put this underneath Mingru. This whole thing. I'm going to put our default encoders and decoders up top. How about like this? We're cleaning stuff up right now. That's what we were doing. Guess we got like 100 something lines of extras bottom. Logits, very nice. Let's start looking at what we actually have here. Linear weight.dtype. This is how mixed precision works, right? I'm pretty sure, yeah, this is. So we have it correct here then. Model anthropic employees. Nah. I mean, I think that they're nuts. Like, if you've actually ever talked to any of the anthropic people, they are insane. It was truly just all the crazies leaving OpenAI. A lot of them truly mean well, but they're just like, they're incredibly, incredibly out of touch people. Trying to like define the future, but they have absolutely no grounding in reality. Hmm. I'm looking at this. What do we think about this? Is continuous. €30 million in AI. I don't think you're going to see too much AI coming out of Europe. Even something like this looks kind of gross to me. Am I being overly critical here? If I just do this, hang on, does this still work if I just convert this to an int? Oops. There's something weird with torch on this. This should still work, right? There's no like requirement that the signatures be let's do. I just want to try something real quick. I think that there is a Torch API requirement that like you can't use ints or some weird bullshit. I want to see if that's the case. It might not be. I could do this with just like Vim find and replace, but there's a greater chance that I screw it up by like messing up the like something else already exists. It's called hidden or whatever. Hey Mustafa. I guess then the question is going to be on the signature. We need to figure out the signature in the meantime. Is there a good way to do this? I have it at the moment, I believe. So the Python version can return a distribution. That would be better. Yeah, sadly, there's still. The more I'm looking at this, there's still going to need to be some clouding horseshit until I get rid of a few more things. Then let's look at Mingru layer as well. The other thing I'm not sure about, so folks, if you're gonna look at this, right, we have conditionals on this seq length is 1. This is the eval path versus the train path, and then we additionally have the kernel versus non-kernel path. This seems quite janky to me. Okay, this is at least somewhat cleaner, right? The way that the way that C++ handles class variables is a little annoying. Would you explain what this code is doing? Hello, welcome. I'm Joseph. I work on Puffer. PufferLib here. This is the fastest reinforcement learning library out there by a very wide margin. We have a whole bunch of demo environments here, lots of games, but also drones, driving, and more. I stream all the development. This in particular is me working on cleaning up Puffer 4, which is our new release that introduces 14 million step per second training with a custom C++ backend, custom kernels, and more. And I'm currently working on cleaning it up and removing some of the jank that was sort of associated with development here. That's like one startup in SF. That France, yeah. I don't know, the startup stuff has been kind of ridiculous lately, though, man. Like, the thing you have to realize is, uh, raising around, like, that's not real money. You know, if you raise $200 million, you don't just get $200 million. You've essentially taken out a very high interest forgivable loan that you can only spend on the company. Check the website, yeah. Hey, that guy. Oh, hey, that guy. There's one really awesome thing I came up with yesterday that I think you might appreciate this. Um, Check this out. We have no templating garbage and no required launch functions for dispatch in any of our kernels. You just compile the build with -d precision because 99% of the time you're going to be using bfloat 16, and you pretty much only ever need float if something is numerically unstable and you want to test. So you just can recompile with d-precision float to test. But other than that, you just have like CUDA C, and this removes 1,000 lines worth of dispatch and templating and garbage. Look at that. All the kernels are just like this with precision T, and that's it. RTTI, you're not gonna. If you're using RTTI, what do you mean if you wait? If you're using RTTI, one-time type information. No, no, dude, it's compile. Because look, it's this flag is compile time. It's, you see? It literally just macros the type. Previous implementation? Yeah. Well, I had to go through a couple of iterations to get here, man. And then I had the insight at dinner. Oh, a Torch uses... Wait, Torch totally uses runtime type information, though, dude. That's how they do it. They have a dispatch macro that's conditioned on the tensor D type. I'm pretty sure. It is technically fast regardless, though, for us, because you got to remember everything gets CUDA graphed. But yes, there will be a small performance hit for non-CUDA graph. Right? Oh yeah, I got one other thing. You may or may not know this. I couldn't reach your X via J Suarez 5341. It's J Suarez now. I got X got me hooked up with the handle without the numbers. Wants to run the model in BF16 and the optimizer in FP32. That's how we do it anyways, dude. Like the mode that you would obviously want to run it in is just the mode that we already have. It's accumulate in FP32 with a flag that you can set to go to a 32. And if we wanted to add a different precision, it would be like 2 lines of code change. I do have one question for you actually on architectures. I don't know if you've ever if you've done much with these what are they called? What are the Mamba like state space type models? Hang on. Do you know if this expansion factor thing matters? This expansion factor param. The idea is that they they can project to a higher hidden dim, and then do everything, and then project back at the output of each block. Beyond my knowledge, cool. I can't see any reason why this would matter, so I'm just planning on not including it. Like, I can't see why it would be useful. Ablate it? I suppose I could. It's kind of annoying though, because like we'd have to change our kernels, dude. Because it puts an extra layer before the output gate. I'll think about it. Maybe I won't delete it just yet. Oh yeah, one other question for you. So I just want to bounce some stuff off of you. So do you have a Python mode that would let you run quick ablations? Yes, I do. Um, they're not quick though, because you literally lose 5x perf when you go to Python. That's how fast Puffer is now. And also torches, like if you try BF16, torches BF16 is not stable for this. Our numerics are now better, which is pretty awesome. Like obviously, if you think about the design, our numerics are going to be better, but it's still pretty awesome to see. The one other thing I wanted to run by you. So apparently this thing lets you run mapmols without a kernel launch. Like you can just do kubelas mapmol inside of a kernel. So if this exists, like, what is the point of us having, like, why wouldn't we just write the entire network in CUDA? Like, this was the only op we needed. How new is it? I don't know. Like, realistically, though, this is super simple, right? Like, NVIDIA has a kernel, and it's not open source, and they expose the host API. So, like, if you just copy pasted their kernel code to the start of your kernel, it would do what this thing does. So I'm just wondering, like, with this, can we not just write our entire networks in CUDA now? Isn't that way better? Like, it's not any harder, right? CUDA is C. I like C. Presumably, you have to set up a little bit just to get debugging working, but like instead of having this stupid bind to module and then invoke kernel, it would make the code shorter too. I don't know. I added Peru in the Discord. I don't know if he replied. I figured he would be a good person to look at it. It supports the narrow use cases. I don't have narrow use cases, man. We got pretty broad use cases. Model arch? I mean, this is not a trivial model architecture at all. What I mean, like, if there's an NVIDIA attention kernel, for instance, that's not supported in this, you would mean? Like, yeah. But then you just go back to the old one, right? You just, like, whatever is the operation that you need the host call for, you just take out. So you basically just fuse the entire passive stuff that is supported, and it's still like incremental improvement to simplicity. Looks quite nice. Oh, this is kind of annoying. Global. Dot execute. Yeah, is it templated only? Okay, I guess we'll have to look at it. I mean, you see how annoying this is, right? Because, like, literally, we just need the matmul code. I do wonder if you can beat NVIDIA's matmul for, like, smaller matrices. Probably not, right? They probably actually bothered to tune it for even small mats. I don't know. I'm partial to NVIDIA. I think of all the big companies, they have the best engineering. Oops. We're mostly just cleaning up Puffer today. I deleted 3,500 lines of garbage yesterday. 2K were stale code, but like the rest of it was actually actual simplifying improvement. You wouldn't see things like flash attention. Oh, this is great. I don't know if it's the best. But this is also the template library, right? I mean, I pretty much just want, like, the more I think about it, the more my ideal library is just like kernels.cu, right? A bunch of kernels with the code. And not like launch functions exposed, actual kernels exposed, so you can just like, call the kernels from inside of other kernels. Which essentially just means like raw C that like it's just C for GPU and just eliminates a lot of the bullshit on specific hardware. Fair. But they don't do more RL, just producing. They do, Jess. I've heard that there's some stuff that they're doing that's probably using Puffer. So I think that there are at least some people there that are aware of it. Yeah, I wouldn't mind NVIDIA could chuck us a nice contract. That'd be good. And we're pretty much just doing stuff for their chips now, right? With Puffer 4. My assumption is that like most likely NVIDIA is going to continue to have the best hardware and the best interfaces for everything. And even if they're not, like um I would hope that any useful chip has a low-level interface similar to CUDA anyways. So the port wouldn't be bad. I pretty much have no interest in TPUs if they're intended to just be programmed with jacks. That's completely unworkable. If TPUs had a CUDA-like interface, I'd be way more interested. But they're not, so NVIDIA hardware good. Like, realistically, you don't even need the entire ecosystem with XLA. Yeah, but XLA is not human writable, right? It's a mess. So in my mind, that's just fundamentally the wrong design. You can't have the low-level interface be something that's not human readable and writable, and then have fucking Python be the actual interface. Yeah, but XLA, Torch XLA is a backend, right? It's code-gen, it compiles to that. And it's super slow as well for small models. And you have basically no ability to do anything about it. Because you don't have a CUDA level interface. Like, you don't have something on that level. Like, look how simple this is, right? Look how simple this is. This is like a fusion of 20 or 30 operations. If you do this in naive Torch or naive Jax, even with their compile modes on, which will take forever to even build, it still produces way slower code. So, like, why would you spend your time banging your head against a high-level framework when you can just write out the ops, and it's just fast? Like, you don't have to get the compiler to produce the correct ops. You just write them. This makes way more sense to me. Okay, let's see if we can get... We have a couple decisions to make. And actually, we'll be taking suggestions from chat here on what to do about this. The first thing I really hate about this is how we're handling mixed, continuous, and discrete. Or how we're handling continuous versus discrete. This seems like really bad. First of all, we have this dot expand as, which is completely unnecessary. I think expand as, is this a view op? See, do I trust this to be a view? A new view with singleton dimensions. Okay, it is a view op. Does not allocate. Okay, so this expand op is actually not that bad. I thought it was just copying, like, in memory repeatedly. But we probably have to call contiguous on this with our kernel, no? It's so janky. Let's go see how this works with training. Discrete, categorical, continuous. So you get logits, reshape, log, std. Oh, you do end up with log standard dev, right? Log standard dev. Wait, but this thing is never, I don't know how much I care about optimizing the speed of the continuous path at the moment, though, to be fair. We literally have one continuous end, and we're not even sure if continuous is a good idea in general for action spaces. Like, multi-discrete is way faster now. Oh yeah, that was the white whale, right? That guy, like, multi-discrete sampling is just super fast now. Look, I'll show you how easy it is. It's actually faster than the expanded single discrete by far. It's right here. Just this. Okay, maybe not just this. This is still a fair bit, but it's just a loop over num actions and then the individual op. And now multi-discrete just works. Logits or mean. This would be better, right? Pretty much that should be no overhead. Yeah, that should be no overhead and good. It's a relatively small improvement. I think that this would be better. Because even if I have two separate pathways, right? I think this is better. Log std. think this is fine. And I think we can have this be null now. So this is the first pass, but I think we can have this just be null, like this tensor be null instead of empty. Me and the reshape. Let me make sure it's not screwing us up here. Don't delete my comments. Okay, so I think that this will be fine for this. Do people have ideas on what to do? The next thing that we're going to have to fix after this is going to be this kernel's path here. Look how gross this code is. Because there's a different path for training and eval, and eval and training, and then there's also a path for custom kernels versus native. So, do people have ideas on that? This stuff. Okay, this still trains. And then we're going to build squared continuous, which is our continuous test env. Also still trains. Cool. Okay, so now Why does this need an empty tensor? Like if I go PufferLib ocean. Yeah. Do logits. Where's the output? Oh, output is the int. That's fine. How is the process from removing the bad code? It's going. What do people think? Do you like the way that this looks? I can also do it like this. So we group the narrows together. I like. That's the main one, Jess. I want 5.0 to be a smaller algorithmic update where we just check a couple exploration things. I have one other exploration project going on that's not public because it's an academic collab that could very easily make it into Puffer 5 as well. But it's basically just like a couple projects around exploration and pure algorithmic improvement. And the main thing that matters for those is going to be having a good number of useful test M's that we can run very fast and stably. Chess will be a very good one. When is the paper coming out? There's no draft of a paper yet. It's an active project. We don't have results yet. We do have some like pretty cool initial stuff though. We should have more on that collab in a week or two as well. Okay, so that took a little bit, but I think this is decent now, right? What do we think about doing this? Do you always prefix your bools with is? It seems kind of dumb to me. I like this more, I think. This is short. I think I'm gonna have about $1,000 in Anthropic bills for the month, which in the scheme of things doesn't matter, but is incredibly stupid. Because like you hear like, oh, $1,000, like it must have been really useful then. But like practically, if this thing, if something makes me, if something saves me 10% time, even if it's just by automating the really, really stupid parts of my work, like really obvious refactor ops, that's easily $1,000 worth right there, right? No question. So like the price I've paid in token is not really a good reflection of much of it being smart at the least. Okay, next thing is going to be, oh, let's actually make sure that this works. Let's not jump the gun. Oops. Let's go. Works. Yeah, Codex and ChatGPT. The token limits are really shit, though. I don't ever want to hit token limits. I just use the API. Okay, so the next thing here, like I just use the API and I stick $100 on it every time I run out of credits. Okay, so we have, the next thing is to figure out how we're going to change this. Min grew layer. I think this is going to be, actually, don't we have policy? Yeah, so this should go, this needs to go down, or this needs to go up in the code. That way we get the full picture, right? Min grew, where is it? Min. Yeah, so let's look at how much code this is, right? So this is pretty much the entirety of Puffer 4. Like, this is the heart of it here. It's this op. Add in your contracts that they pay for credits. No, people don't like that type. People like when you just give them a price. Like, our prices will just increase over time, Jess. Nickel and diming people is not the way to go in business. Generally pretty trashy. It's like when you go to a nice hotel and everything is like twice the price it should be for like basic amenities. It's just like, come on, right? Well, okay, this is not as bad as it looks. The reason this is not as bad as it looks is I believe we should have this logic down here. Yeah, fuse scan right here, this op. Right? Like what happened? Can I not just, if I copy paste this up top, it's the same code, right? Yes. Okay, so yeah, fuse scan CP. Yeah, we've got some duplicated code. So this will look a lot simpler. Good. These checks are already done. Oops. Don't need the dex. And then this goes like this, right? Boom, boom. Oop. Oops. It looks good, right? Hey, Liberty. Oh, and look, then now this is also redundant now, right? What were the results of the training? Oh, of our sweep overnight? Really good. So we have a 6-minute, 1700 some odd score run. No, 17,000 some odd score run, excuse me, in breakout. No, not breakout. 2048. So that's really solid. Now, we have a way better run in Puffer 3, but it was run for much longer. So I need to do like a much longer experiment with this and probably longer sweep. But like for a first overnight run, this is about as much as I could have asked for. And it replicates as well. We retrained it, it replicates. All right, this piece of code here. Min group gate. Oh, wait, you can't do this because, right. I think actually, it's a little iffy. Yeah, that's kind of what I was thinking. Oops. Damn it. Okay. Can we get cleaner than this? Wait, result of 0, result of 1. Isn't that just result? Vector of tensor. Yeah. It literally is. We could do this. This is kind of confusing, though, don't you agree? Read all through 30? No, that's not my, like, that's too broad of a domain, man. Let me see which of these I've read. This is very good. I actually haven't read this. We do not use transformers in our RL stuff. Yeah, I read this blog. How many of these have I read? This. Maybe this, I forget. This. I think this one. I don't know if this is the same one I'm thinking of. Yeah. Yeah. This one, this is the course. This is the good course. It's kind of an odd reading list. Well, this is very much LLM pilled as well. I think you miss a lot with this. Like, there's some stuff in here that doesn't really matter too much. And this is very LLM pilled. Actually, it's not even. It's kind of like it's a weird transitional list. When was this? Oh, 2 years ago. I mean, I have my own list for RL in my article, right? How long does it take you to read a paper? It depends how much I read it, man. It could take 3 months to read a paper, or it could take like 5 minutes to read a paper. You know? 3 to 4 years ago? That makes sense then. I actually learned yesterday, apparently Ilya was the one who wanted OpenAI to go all in on scaling. Though I heard that secondhand. I don't know if that's actually what it was, like the actual quote. I think these ternaries are kind of crap. What about you guys? Hey guys, option A, B, or C? What do we think? A? We could also do, there's a variation on this. We could do, we could flatten it. I think this is more complicated to read though, right? A or C? Yeah, I don't like B. I think this is too much to one line it. Oh, hey guys. You dingus. I think we just do this for now. And then there's going to be another opportunity, I believe. We can get rid of this expansion factor thing because we don't support it anyways. Now that I'm looking at it. Good? I think that's good. Which AI lab is the most talented? I don't know anymore, man. They've all gotten too big. Despite all my criticism about OpenAI nowadays, I've been very public in saying it's the best place I've ever worked. When I was there and it was 100 people, it was awesome. Like, it made Stanford and MIT feel like a bunch of drooling idiots by comparison. But now it's a 1,000+ person company, right? Like, you don't maintain talent density at that scale. You just don't. Hang on, this has forward and forward train anyways, doesn't it? Let me try this first. Make sure I didn't break it. I probably did, because it probably is like going to have expansion dim or whatever in it. Math, it's figured out during learning and doing stuff. It depends on what your focus is, man. My work is way engineering heavy, right? Like at least 80% of my work is engineering. I understand architectures, right? I understand the core learning algorithm I'm working with. I even do a little bit of algorithmic work, but it's like 5% math for me. It's mostly eng. How much is basic requirement? You definitely need to know math at the level of CS 231N, which pretty much you need to know the chain rule for partial derivatives, and you need to not go nuts when occasionally a matrix gets flipped in and gets transposed in the derivative. Sometimes cross terms, but usually not. That's about it. It's not really that serious of math. It's certainly let's put it this way, it's a lot less math than you needed for machine learning before neural nets came about. Now look, if you're going to tell me that you want to specialize in diffusion, that's a totally different story. Like, general engineering math is also helpful. But in my view, like, the majority of progress being held back is by people being bad at engineering, not being bad at math. And you can go to MIT, there are a whole bunch of people that are really good at math. There are actually comparatively very few people who can just program stuff that is not awful. I don't necessarily think that you need to be smarter to be a good programmer either, but it's a very different way of thinking. And it's a way of thinking I very much enjoy. Programming is very close to just logic to me. I don't know, people say like writing, like clear writing is clear thinking. This is like that, except without the whole bullshit psychology element, where clear writing is actually not at all clear thinking and you can kind of lie. The code just is. What is going on here? State tuple vector. I see. That's fine. That's fine. Do you think in language or visual? It's mostly symbolic. I don't know. Hard to describe. How'd you end up in more engineering than programming? Well, I started learning a bunch of math when I was getting into research, and it was really hard and it wasn't actually that useful. And then I started doing some engineering, and it was still kind of hard, but it was really useful. And then I just kept following the gradient of what was useful to my work. Like simplicity is not really subjective. It's only subjective within a small set of bounds. Most of it of good engineering is about making hard things simple, like making complex things simple. Like for instance, right? This versus the one-line version of it, there's some subjectivity. But this versus the original, there's no subjectivity. Right? The original, I had like 3 times as much code as this. It was worse. This is now better. There's no subjectivity in the matter. And then you're going to see like the code will just be objectively better by the end of the day. Did you ever feel stupid at MIT? No, the opposite, dude. I got there and it was like, wow, all these people are really dumb. Because OpenAI was way, 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 way better than MIT. Same for Stanford. because I did 6 month internship at OpenAI. I like finished my last quarter at Stanford. I graduated a quarter early. I was working on my research independently for like 6 months before I started, and then it was like, wow, this is really not actually that great. There were a few cool people, a few very smart people, um, but it was like nothing like what was at OpenAI. But like, think about it, man. How the heck am I going to get to MIT and feel stupid when I'm there to do research, and I'd basically already spent the last, what did I start PhD at, 21, 22? So I'd already spent the past 5 or 6 years of my life full time just doing research. How much was paid during your intern? I think it was like 140 annualized. Which for an internship back then, they actually surprisingly paid more than like most of the like the bigger tech companies did for interns. This is back before money dropped like by 2x in value, right? Like your money, like everything was half the price back then, you got to remember. The COVID era inflation was just utterly stupid. Like lunch in California back then was $7. Clear your debt. I did not have debt. And generally, loans are like far less common at the top universities, SFing in the US. And they pay less. No, they just don't have internships, not officially at least. Who saw you more? Understand. I never saw Elon at OpenAI. I don't know if he was still there. I think he was already out. I don't actually remember. Sam gave a couple of the all hands. He said some good stuff, but I couldn't read him and I didn't really trust him. And that was apparently proven correct. Um, Greg and Brockman were very smart. A couple of the younger people there were awesome. Like Alec Radford was awesome. Uh, there were a few other people there that were just like really good. Oh, some of the people on the Dota team were just very, very smart. Like they had figured out stuff in RL that pretty much the field still does not realize for the most part. Scholarship. No, SFing, the way it works, so pretty much the top universities in the US, if your family can afford it, your family pays. Otherwise, you get need-based financial aid. It's not like a scholarship thing. At the top universities. If you get like into tier two, then that's when people start taking a lot of loans. Who can lift the most at OpenAI? Brockman. Totally Brockman. Well, it depends what you mean lift the most. He does Olympic lifting, so it's more technical, but he is in very good shape. How much research done in OpenAI was published? When I was there, I would say that the vast majority of research done was published. Almost all of it. It was very, very cool. That's like the thing that's why I wanted to be there, right? Like it wasn't because it was a non-profit or whatever. I didn't give a shit about that. It was because it was published. If OpenAI had continued on Dota 2, yes. OpenAI, like, they set back the field of RL by a decade by not continuing on the Dota stuff, and at the very least, like, not releasing it fully. Family pay? Yes, that's that thing. I mean, I was very fortunate in that regard. But it is the case in the United States, at least, that if you are smart enough to go to a top university, you're not going to be saddled with a ton of debt. At least most of the time. There are some exceptions. I believe like if your family has money but won't pay, and then you don't get financial aid, and you have like there can be weird stuff like that. Um, but for the most part, like you're pretty well off. And also at the top places, anyways, if you're in a good field, like you'll pay it in a year or two, anyways. The student loans being like really crap is more so for uh, not the top universities or fields if you're in a field that does not pay particularly well. GDB, yeah, it's cool. Who can run the fastest open? I don't know. No idea. I'd say most of the people there were not in particularly good shape. Most of them were like very scrawny academic types. I was back then as well. When I was there, I weighed like 135, maybe 140 pounds. All this training was during my PhD and like since then. How can people survive the work intensity if not in shape? Um, it's easier when you're younger. Like you basically have a span of years from 18 through early 20s ish or 16 to early 20s where you can kind of just get away with it and drink a lot of coffee. And then after that it's like no, you got to be in shape. Who's the most handsome at OpenAI? I don't know, man. Ask a woman. I'm not for evaluating men's appearance, thank you. And said same journey like Netscape. I mean, I think OpenAI will likely still continue to be worth a lot and make a ton of money and like have a bunch of deals and build some LLM stuff. But unless they massively pivot, I don't think that they're on the path to just solve everything with ChatGPT 7. I think that they really fucked up by abandoning their RL core, and that knowledge is now gone. Like the people that are doing like that knowledge is gone essentially. And I think it would have been lost completely if not for what I'm working on right here. That's why I'm doing it. Now the trade-off is they're no longer going to own this, right? This is now just going to be out in the open. Everyone will use it. It'll be good. Best current lab. Funny enough, probably DeepMind. I think they're the only ones that are still actually considering a whole bunch of different problems that we can solve with different methods in AI, rather than just like, going all in on language models and hoping that builds machine god. Like they are still doing a lot on language models, but it's not just that, and that is good. That's a very good thing. I mean, a good thing for science, right? I don't know if it's a good thing financially or business wise. I don't, whatever with that, right? It's a good thing for science, is what I mean when I say that type of thing. Deepest minded Google. All right, enough with the silly questions. Uh, survive the AI bubble burst. I don't think that there's no AI bubble. There's a little bit of an LLM bubble. Okay, a lot of an LLM bubble. There isn't an AI bubble. I do hope that when like people realize they're not getting their money back on some of the LLM investment, um, I do hope it doesn't have a ripple effect and kill off a ton of other research. The cool thing is I'm kind of insulated, right? Because, like, I'm not in a space where I'm burning tons of money doing this. I'm kind of just doing my own thing. So, at the very least, I can sort of just do this indefinitely. Frankly, if the LM bubble does burst, it'll probably make it easier for me to pick up like some really, really good people that are looking for something new to work on. I don't think like the average OpenAI employee is good enough, but I think that they do have some fantastic engineers and researchers there still, even if the talent density isn't just what it was. But there's also like a very specific type of person I like to work with as well. Like, I kind of like to work with people that understand what are the right problems to be spending their time on. And like when they get stuck in a rabbit hole, it's going to be a rabbit hole that actually has some chance of being broadly useful and not just like, oh, this is an interesting puzzle for me to solve. Until when do you still accept M's for Puffer 4? Until pretty much right before Puffer 4 launches. Standards too high? Not really. It's just it's impossible to scale. It's impossible to be hiring hundreds of people in a few years and still have talent density. It really just depends on your mental model. Like in my mind, engineering and research skill, it's very, very firmly exponentially distributed, right? Where like a really good researcher is worth exponentially more than a mediocre one. You can get good very quickly though if you have the mind for it. I'm kind of been thinking about how I want to look at this, right? Like, do we need a Mingru layer? How do I get good quickly? Follow RL guide. It's worked for others. I mean, there's something of a mindset thing, right? Like, you understand what problems you want to work towards. You understand what tasks are likely to actually move the needle towards that or not. You understand what things you need to learn to get there versus what things are likely to be a waste of time. It's only 100, 200 people who matter and make a difference. Yeah, that's fair. I mean, it's the thing is AI is now broad enough that it's probably more than that. Like I would believe that in LLM specifically, it could just be a couple hundred people really doing anything that's super useful. Yeah, I want to try something. Self-play. Do you think we should go? How do you think we should go about? I don't know how you're doing it exactly, Jess. Why don't you raise from VC? You can get 50 mil seed. I'd have to probably get a couple co-founders additional to bring on for that. But like, I don't want it, dude. That like, what does that do for me? Like, think about it. What does that do for me? You don't just get 50 million for yourself. It's like, that's not how it works, right? Like, do you understand what that actually means? Like that means I can hire 10 people for maybe 4 years. I have a whole bunch of strings attached to me on like what I'm actually allowed to do and how I have to go about things. I have a huge amount of overhead in management and in communicating shit with VCs that prevent me from being deeply involved in day-to-day work where my skills are actually best used. Not worth it. It's more than just giving up a part of the company. I don't really think it does 24. I think actually it dramatically decelerates my own research and basically just it's basically on puts a lot more of the onus on who I'm hiring. Like I've spent a long time getting very good at my own individual dev. I can make a huge amount of difference as a single individual. So like basically replacing half my time with management is not a good trade-off. And then plus putting a ticking time bomb on like a long-term research project for running out of money, like it's just a bunch of stuff is not worth it in my mind. I'm really happy I'm doing stuff the way I am. See if this works. Like I'm pretty darn confident I'm gonna have RL set in the next couple of years anyways, opposed to having founders. Oh, that I'm not necessarily opposed to. Though I'd rather it be with people I've already worked with, you know? Like I don't think it's a good idea just to go get random people. I just said like to get 50 million, I'd have to go do that. Like I could go get 10 or 20 without doing that. What would you need to know? Probably can clarify. I guess I would need to know specifically how it is you're like using the other policy for the 20% of data and stuff, Jess. You've kind of seen me deving this stuff, right? Like, is it just adding some logic to the C++? And is there a way we can do this without messing up the non-self-play path? Speed up puffer research if people founded companies and also do research. VC's badging. I mean, I get lots of emails 24. I mostly ignore them now. I spoke with while I was in California just for the hell of it, because like I got a few good ones um messaging me. So I had a few meetings, and there was one woman who ran like a small firm who I actually really enjoyed talking to. Cocoa actually. She was like really, really good. But all the big ones, like holy hell, it was just not enjoyable. I mean, like literally, I would go sit down and talk to them, and they'd be essentially trying to figure out my angle with the whole open source thing, right? Like, they basically have everybody reduced to purely maximizing dollars and not giving a shit about anything else. It's like, if you could legally pivot to selling fentanyl, like, they'd be all over it. It was that type of people. How many VCs really understand tech? Some of them sort of do. There are a couple that are actually fairly technical, but like, no, I don't want to be beholden to people anymore. I want to do my own thing. I'm very good at it now. I'm doing it very effectively. I don't want more bullshit, right? I don't want more noise. Like just the clarity that I have now over research is so valuable. I want to keep that and I want to keep going on that. Okay, let's see what's happening here. I think that this is like, whoops. I don't fully like how this is. We have policy mingrew. This is actually not bad. And this is still fast, right? Yeah, same speed. Bad perception of open source. Mm-hmm. I guess, like, I know, I suppose lately I just have this model of the world where there's so much noise. And actually, a lot of the problems, you don't need money to solve them. Like, you don't need a team of geniuses. You don't need 20 years. All you need is to simply take a step back from all the noise and look at the problem and just start solving it in the simplest way possible. And you can make a huge amount of progress. And you can make stuff exist that would otherwise not exist. That's incredibly important that it does exist. Yeah, this is mostly just a bunch of checks. Don't need expansion factor. Which was more research oriented? To MIT. The MIT people were technically better. The Stanford people had a little bit more perspective. It's better. Do you meet Feifei? That was my first internship. I interned in Feifei's lab with Justin when I was in high school. I actually met her recently for the first time in 10 years, um, over the summer at her new company. I happened to be in the area, so I just showed up and was like, "Hi." They work crazy hard. No, I don't think most labs. It's not like everybody works crazy hard. Like a lot of the pressure in a PhD environment is self-imposed. So there are usually some people who work very hard and some people who don't. Carpathy and Justin were both pretty obsessive about stuff. Olga as well was, I remember Olga was there working on the ImageNet challenges, was pretty cool. Haven't even married? Haven't they? I don't know. I mean, not all of them are going to be posting stuff over socials if they have. Push their students. No, it's really individual. Like my advisor pretty much just let me do whatever I wanted. I mean, I did work fairly hard for at least a good number of those years on neural MMO and stuff. Nothing too crazy. I probably work a little bit harder now than I did during most of my PhD, frankly. And I'm definitely way more productive. still don't like this. Let me see. Auto result. Most PhD work is not useful. Most industry work is also not useful. Most work in general is not useful. So it's kind of a non-statement. Supported by grants? Yeah, all PhD students pretty much are supported by grants. Your professor goes and gets some grants and then sticks you on some grants that are like vaguely related to your work. Forward and forward train, huh? I think it's not bad. This is definitely getting closer. Yeah, it's definitely getting closer. And then what we're gonna do, right, is like we can even add the LSTM as a backend for comparison if we feel like it. There's policy star. If they let you do whatever, then they might not get. So the degree to which the grants have influence over your work depends on the lab. Most like talented PhD candidates though are not going to sign up for a program that pays them $30,000 to $40,000 a year to be like told exactly what to do for 5 or 6 years. That's just not how it works. So, I mean, like, think about it, right? Like, hey, like, you're smart, want to be paid some peanuts to be told what to, like, to work on some stuffy thing that you don't care about for some company that's paying, like, a fifth of what they would pay you if you were just working at there in person? No. Wow, really? Why not? So, usually there's, you find a professor who has an area of interest that matches your own, and the agreement is that you're going to be generally working in that area of interest. Some professors have specific projects that they want people on, and they say, "Oh yeah, we're hiring PhD students." Um, Most are not that way, I would say. Well, it depends. It really depends from university to university and such. Yeah, this is good. Corporate PhD projects. It depends on the corp. I think that people that do like the half at DeepMind, half at Oxford or whatever, like those are pretty good. Tons of work only for the company to say nope, you can't publish this. Yeah, so straight up, at MIT, like you can't agree to take work with those restrictions. A lot of the good labs and universities, like the professors are literally not allowed to take work with those restrictions. How useful is research from the university? It depends, right? It depends vastly on the project, on the student, and on everything. It can be tremendously useful, it cannot be, same as everything else. Mm-hmm. 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 No Claude today? Yeah, we've still got some shitty refactor ops, unfortunately. It's all gross C++. The one thing I will say is that in the process of doing this, there's less and less gross C++. So far today, here, this is what the decoder looks like now. Not bad. This is what MinGroup currently looks like for the multi-layer one. I think I can clean this up still a little bit more. And I want to clean up this policy, but we're minus one class, minus a decent chunk of code. I mean, it's mostly the fact that everything looks like this in C++, right? Like, look at this crap. I would like to get rid of things like this. I think this is a torch thing, though, that it requires shared pointers. How do we get continual learning? Mm, I mean, honestly, I think the problem is kind of poorly framed in the first place. Like, people sure as hell don't solve continual learning. Okay. Let's see what we have left. We do get a single policy out of this, which is very nice. The Ford just becomes this, which is very nice. You removed my torch checks, you absolute fuck. Okay, this is what we expected. Let's make sure this still passes. And then we'll figure out the next set of fixes. This is where we want to spend most of the policy effort, I would think, is on just having a really clean base policy. Mammals are dumb in a bad way to do neural nets. You need, if you have an alternative, you also need to be able to have hardware that works for it. It is entirely conceivable that you come up with neural nets based on a different operation. It's kind of meaningless if you don't have hardware that implements that operation efficiently, though. Okay, so 2 screens of code pretty much, right? 2.5 screens. I still think it's worth putting more effort into making this thing less jank. Because this is, if anybody is going to be reading the policy code, this is the main chunk of code that they're going to read. And I don't want them to look at this and be confused. I think that this should be like the super simple thing. I'm gonna use the restroom real quick. I'm gonna grab myself a mug of tea, and we're gonna continue on this. I'm on all day. Like I got another 6.5 hours to stream probably. I'll be back. Okay. Evolution is kind of a meme, dude. Like, it's a really bad optimizer. Next thing here. Layers. I'm just gonna go mark a bunch of things I think that I don't like. I just don't like all the C++ jank. Fundamentally unserious. What? That's funny. Even more mathematics and less marsupials. Catch them. That's funny as hell. This parameters. Isn't this? I have a big exit in data. What? RLMMO is a long project. We still use it. There will still be future versions, most likely. Stanford is dope. Yeah, I think it is the best place for undergrad. You can make yourself absolutely depressed. All you have to do is take 22 units of, of, well, real classes in the winter. If you don't do that, you're pretty good. Project is very good. Like, what? How does Puffer box thing work? I don't have any personal GPUs to test on. We have like 10 desktops. We allow contributors to gain access to them, but we don't give them to just new contributors, right? Like, you have to have actually done something that demonstrates that you're producing something that needs compute for experiments. Otherwise, everybody would just be asking me for access and not actually do anything. You do also have to sign, for access, you have to sign a EULA that says you won't do bad things on our cluster. And then you just get direct SSH to a box. Has Docker set up already in it, boots you straight into the container with Puffer already set up. That seems wrong to me. Vector. That's bad. Well, maybe it's not bad actually. This kills this cast and this cast. And then what in order to do this, we have to do what's the rent? Just rent the GPUs? Wait, what? Rent the No, I own the GPUs, crit. We have physical hardware. You can rent on Vast. Sometimes they mess with the machines a bit. We thought it was better to just have a bunch of boxes. All robot learning labs in one pit. Oh yeah, they do have that, right? I don't know. I haven't really been over to the robotics people much. A big AI, big environment. Neural MMO is a big AI environment. Yes. Hey, user. Does anybody understand this specific piece of C++ jank? Like, why does this cast exist? I think I'm looking at the code and it's like, the structure is mostly fine. There's just little bits of littered C++ jank here and there that we just don't need to deal with. That's the main thing that's bothering me. So let's say that we finish this up in the next 20-30 minutes and we're happy with this. Probably I can have it port the LSTM as a backend just for fun to see real quick. We'll take a quick look at this stuff. I think this is mostly fine. And the rest of this is pretty simple. This is a quick cleanup, so we'll be done with the models file in like an hour tops. Warning for clean models files fine. Okay, so this is fine then. Let's do this. So we just don't use module list in C++ then? So what does this look like now? Required for polymorphic module. Shared torch register modules needs it. Annoying. Polymorphic modules. Yep. This should be substantially simpler. And then this int updates. Okay, now we get to look at what we have again. I don't know if I like this one. That's nice, right? So we keep the NN on the space. Yeah, that'll save quite a bit of yeah, that'll make things a fair bit shorter. Including, like, this should just be a little bit more readable. Tensor. Good. Oops. How'd that happen? Oh, because it literally just ran a replace all. Cool. Make sure this still works, and then let's see what other jank there is to remove. Okay, good, works. Now, so we got min grew. This is fine. Which existing env has the most expensive step function? It's probably something stupid like Connect 4. No. Maybe Go. It's probably one of the M's that has a stupid scripted built in. Most expensive usually just means least optimized code, though. Just have Blood Plus. No, I'm just using the API at the moment. Power grid ops, we need. Yeah, you don't want to have you don't want to do that. You don't want to have a first end with an expensive step. You're not gonna have fun. L. D times num layers. Initial state of batch size. Maybe you can use this with whatever. So I messed it up somewhere along the way, no biggie. I'm just not seeing this. This is super basic, right? Oh, right. Yep, this is fine. Forgot about that. That's super obvious as well. I should not have forgotten that. I thought you could do equals equals. Like, yeah. That was dumb. Boom. Okay. I think I just have to figure out what torch checks I want, and then we're mostly done with this. You actually don't use B anywhere, do you? You don't use B at all. Oop, this one as well. Okay, so you don't use this at all. It doesn't get used. I don't think we use either of these because size 0. Yeah, so you don't use B anywhere. Okay. There's no reason to have these be new lined when they're such short functions. Go like this. Oops. This maybe. Don't know how we want to format that yet. This is much better though. So many little things just to improve. So like we know the required input side, the input shape here. And then what? We need here is fine as well. So I think pretty much then it's pretty much set. X and state, X shape, sizes. And what's this forward train? Oh, no RNN, I suppose? Do I care about that? Let me think. I don't think I particularly care about this, do I? Yeah, no, I don't particularly care about this path. Because we're just going to do the sampling different. Like, we're going to assume it's segment level. We're just going to assume. Keeps getting simpler. TT is just going to be x dot size of 1. This is getting to be very, very clean though. Getting to be very, very clean. Size. I don't like that we have this reshape here. Oh, this is not good. But I think this is we're going to have to refactor when we do the rest of the stuff. I think for the first chunk, this is like really, really solid progress. Look at this. This is Mingroom. Policy. We're not going to spend time on the LSTM stuff until we fully have the policy done, and then it's just like going to be an automatic quick refactor. So we don't even have to worry about that. What'd I do? Okay. We'll make a quick commit as well. We'll make a quick commit. This works. It does, 14 mil. Nope, not modules. Modules, C++. Cool, and that's also minus some code apparently. So we just deleted another 500-ish lines for refactors. Super nice. Now let's do... Let's just look at the rest of this real quick. So we have, I think that was the main code, right? No, that's the main code. So now I gotta go look at PufferLib CPP and I gotta see used. I had to see how this gets used. Okay, so this is just like directly taking it. Sample actions and a write directly to rollouts. Wait, dot narrow. Policy bf16 dot forward. Are these being flattened? It looks like these are getting flattened. Is it? Now I'm getting confused. So, logits mean dot reshape. No, it's getting reshaped to a sequence value. Why would I do that? For advantages, probably, right? Right, so it's a little bit annoying then because the decoder is meant for flat data. The encoder is meant for flat data. But during training, stuff has to get reshaped, right? Yeah, it's moderately annoying for sure. I'm trying to think, is there a way around that? I don't think so. So I think that is... Let's take one more look at this and the whole thing. Min grew. Hidden kernels. Public. Is it private by default? Default is private. Cool. Struct. Now we get rid of the public keyword. One more C++ thing gone. Still works. Struct min grew. Layers equals 1. This is fine. Torch D type. D type device. Interesting. Okay, your torch check. Select the state. Get combined. Okay, I definitely want to look a little bit at this logic. Is there anything else in here? This is pretty simple. Was this parameters.empty? This is weird, but I think this is for bfloat. Okay. This is pretty tight then. I think that we don't. Let's not agonize over this more right now because we're going to learn other stuff from refactoring the rest of this. We're going to ignore the LSTM for now. Do I want to do this first? I think it's policy next. Not policy, PufferLib C++ next, right? Probably here. Do I want to add D-type? Torch D-type. I'm confused how this works. Export. What the heck? There's a lot to do in this file, actually. Let me get a little bit of a sense of it. I mean, it's just stuff like this, right? Yeah, I'm going to do the same thing as before. I don't like a macro. Isn't float 32 the default? Oh, that's a little interesting. There's a lot to do here, actually. Yeah, this is gonna take me some work today. Let's just get the easy stuff done first. Net wrapper. Yeah, this is just a whole pile of crap, isn't it? Graphs are a mess, for sure. Remove state zeros and reward clamping is sketchy. Big labs hiring high school grads. They're mostly memeing hiring high school grads, frankly. Like, as someone who started research really, really early, um, even if you've worked very hard and are very smart, you just have not had the time to like learn stuff reasonably. Some undergrads can be pretty good. Degrees definitely don't matter, but yeah, it's a little bit ridiculous. Like, it's one thing if you say, like, hey, we think that this guy is really smart, so we're going to invest in this guy, and we think that he'll be good in, like, 2 years. Like, that's really cool to be giving people opportunities to do that. But, like, there's just no way you have the breadth of experience by that age. And I say that as somebody who, like, really, really worked hard. And I was damn good for my age, right? Like, I was already doing some research, but, like, I was just missing so many things back then. Rest of this is going to be harder, right? Okay. I just went through and did, like, some of the really obvious stuff. We start with 11, 16 lines. Probably not going to cut a lot of lines. 45 KB. It's probably going to make, it's probably going to cut some text out, though. CUDA F32. Yeah, that's good. That's good. That's kind of what I was imagining, right? You just do like CUDA, yeah. I don't know, maybe this saves a KB or two. File size obviously doesn't matter, it's just about the amount of code you're freaking looking at. There's like little redundant crap everywhere. Wait, why is... Okay, yeah, this is fine. Okay, so just off of a, like a very quick redundancy thing. Let's see how many tokens we saved, or how many, how much shorter this file is. And most of it is just that. That's the only little bit of dead code to be deleted. I think maybe that and a couple lines of profile. We can leave that. So we are going to lose like I don't know, 20, 30 lines worth of the refactor is going to be moving this function. Min F32. But I think this will be tries to macro shit. No reason. Okay, so 45 KB down to 43. A little shorter. A little shorter. Still have a massive pile of crap to deal with. I'm trying to think what the best way is going to be to piece through this. What the heck is this? Let's make sure this still runs. Okay, we still train, right? Yep. Super fast. I gotta think about where I want stuff to live. There's too much stuff in PufferLib C++. I think there's just like, I don't want to have like torch utils or something. I also don't want a ton of little files. Let me get a refresh on my tea and we'll continue. A moment, guys. All right. Yeah, I still don't know what to do about the about this. Like, there's just a bunch of stuff there's a bunch of stuff that doesn't fit cleanly. Let me scroll through this real quick and eat some soup, and we'll figure it out. Delete this bot. So graphs, buffers, hypers, PufferL, rollout step. Does this actually get used? I actually don't think this one gets used, does it? Maybe it does. Green forward call. Capture graph. Okay, I mean, I think most of the code in here is devoted to... It's like all split up for graphing is the thing. There are only a couple little things that don't super belong. Like this clip norm and stuff. My soup, and we'll think about what to do about this. I don't typically eat much during my my long stream days. I guess one question is, why do we have so many different little split out functions in the first place, right? We've got train graph, we've got rollout buff, env buff, and that's it, right? So why do we have so much stuff? Does it get used? Oh yeah, it does. It gets used in this callback. So we just kind of have too many places where this gets used, right? it's annoying in some sense because, like, you can't just write the logic top to bottom because of the coup de graphing. Well, here's something. We can split all of these out into, all this stuff for the most part can get split out into layers, I would think. Yeah, we basically do the same thing that we did with models. That'll be fine. Let me just have it do this while I am eating. This logic, like this logic. This logic. PPO loss. So that's just some redundant logic right there. Like all this is already handled, right? We also just have too many layers of this crap. Let's see. Yeah, because the sample logic is dated. Okay, this is substantially better, right? Still too much crap. Wait, what? Um, is it hallucinating this? Oh, it scrolled me to the top. Lovely. Fine. Hello, web GPU. So there's pretty much no more policy logic in here now, right? Yeah. So on one hand, that's good. It's now nicely and pretty succinct in models. On the other hand, though, then we now have 1,000 lines of stuff that's like, what is it doing, right? Not too good. I mean, this could go into the models for all I care, right? But then that still leaves us with like 900 some odd lines of crap. So what's all this crap doing? Okay, we've got end of creation. That looks pretty succinct. We've got train graph creation. Got rollout buffer. This is the experience buffer. This is all the experience buffer logic. It's very nice. We got all our hypers. Okay. We've got PufferLib. Maybe has a few too many things defined in it. Probably has a few too many things defined in it. Here's fused rollout step. So this doesn't actually really do anything given that all the logic is here. So why is there so much code? Let's figure that out. So this thing gets graphed. I see, because we have our conditional kernel stuff on this, right? Hmm. So like, let's say that we can get this into a separate file. Then what are we actually looking at here? So you have to select the chunk of each of the output buffers. These calls are just really freaking verbose, is the problem, I think. Like all these, if you're looking at these are just copies, and they're really long because select, narrow, copy, and like, interesting. Let's keep reading. I understand at least where the complexity comes from here. And likewise here now, it's the same thing. Why is there so much cleanup to be done? So you have to understand that Torch is an absolute disastrous mess. It's very, very difficult to write good, clean code on my first shot when I'm also working around, like, pretty much everything revolves around Torch being a total disaster. Most of the stuff I had to figure out is not even documented anywhere at all. I also just have a much higher bar for what I'll ship than those do. Understand where that complexity is. Let's go look at this creation function. Okay, so this is our graphing stuff, right? No, we got continuous discrete here. This goes into Ocean. This is BF16, an optimizer. Here are all the buffer allocations. Here's the graphing. This is definitely too deep. Like, the logic is nested too deep. Okay. This isn't implemented yet, but we need these. We have the annealing here. Quite a bit of logic. And all these profile tags. It's gonna be pretty difficult to get this cleaned up. Let me think about this cleanly. I mean, the main problem here, right? So, anything that needs to be profiled has to be split out into a separate function. Anything that needs to be coup-de-graphed also needs to be split out into a separate function. Custom kernels also create two pathways. So we have two different things that are requiring us to separate things behind function boundaries. And then also coup-de-graph versus non-coup-de-graph is separate. So we have two different things requiring us to split things out into separate functions, and we have two different things that are requiring us to have separate pathways. Let me think about this. Oh yeah, also there's, for the eval, there's the callback thing because the backend has to own a callback. Ugh. There's just lots of different things requiring me to split stuff up in a way I normally wouldn't want to. That's pretty much all there is to it. As for the reason why it's like this, now, how we get it to not look as bad, that's another question. We got our models very nicely cleaned up at all. I think PufferLib C++ should be This should handle the coup de grace pathway. And then anything with if kernel should handle anything like this. This should go into model C++. Chicken noodle that guy. How would I get started on chess? I may try to implement. No idea on that one. It's important. I'm running a 8x8x64 op for targeted locations. Ooh. That's a lot of data. Isn't it? 4KB, right? That's kind of like the highest you possibly want your obs to be. "32 channels for current position." 32 channels. Wait, can't you just pack that into Can you not just pack that into 8x8x2 and have it just like one hot? You can, right? Okay, that's fine. 8x8x2 is fine. That's good. It's simpler than what you did in Pokemon, isn't it? That's a pretty simple encoding to try. Oh yeah, by the way, I don't know how well you did on 2048 before. This is from our first sweep that we ran on it. So we've got to 17K in 6 minutes. And we get some 32K score in that time. No, like, I mean, I don't remember how quickly the models got this score is what I meant. But there. It's pretty cool. Embeddings with Rubik's. Do you not just solve Rubik's instantly? I would figure that would be an env that would just insta-solve. Variance in Epling. Yeah, you just truncate. Just give it a max solve time. And you initialize with a random number of scrambles. I think you should solve. Okay, so we have a whole bunch of these now that take a million different things in them. But this is a start. So now if the models file is responsible for custom kernel versus not. Okay, so this is the actual logic for the most part. So why do we still have 967 lines in this file? Why do we have so much stuff in here? Okay, so what do we have here? Policy, env, optimizer, hypers, com, buffer, states, there's a little bit of fat in here. And now the actual meat of it is this, which is really, it just looks much longer than it is because of the Torch C++ copy syntax here. Like this is just, yeah, these lines should be half the length. Okay. What about here? Forward, train loss, giant function sigs. That's silly. What, the syntax? Yeah. I'm basically just trying to figure out where all the bloat's coming from, man. Like, this is not a trivial thing to build. You have you have stuff that's forcing you to split stuff out on the kernel's boundary, so kernels versus not kernels, and then also on coup de graphs versus not coup de graphs, and then there's also this annoying callback thing for the NVEC. Sizes should be checked at compile time. uh, compile them linear algebra library. What is okay? Here's another question. What is the minimum number of layers we could theoretically have for this thing? So there's got to be a train function, right? Inside of that, there's a portion of the training that can be graphed. Presumably, anything that has to be graphed, you'd have to stick behind a function. Because there's not really, without having a specific function to graph, there's not really a way to do it. So I think you have to have, train, logic, 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 if coup de graphs, graph replay, else whatever. The else also has to be a function call because it's the same logic you're graphing. And then inside of that, you have a conditional on custom kernels, right? The custom kernel is going to be a function call. And actually, even the other path has to be a function call because you need, like, that logic needs to be on its own so you can test it. So you need to have, like, you need 3 freaking layers at the least. And then, of course, kernels goes to modules goes to kernels is 5 layers deep. That is awful. Function overhead or stack depth. I'm worried that deeply nested libraries are just kind of shit. This is not about compiler or anything. This is just it making the code less shit. Because like here, if I just say we have like train, right, and then it's like, and then we have, oops, we have like if graph, and then we have replay, else train function, and then in here we have train function, and then we have if kernel, train kernel, else train native, and then we have like train native, which is like actual logic, and then you have was it class or struct train kernels forward, and then this has launch Was it? It looks like this, right? This is like so giga shit because like if I want to see where's the train code, you have to do like if okay, not this one. So this one. Okay, do I want the train current? Let's look at the native one first. And then you go here. Oh, do you want to support? No, this all has to work. I mean, I'm trying to think. Maybe I can do. Can I do this? I'd see. I don't think I can do this. But like, I don't even think I can do this, man, because practically the graph path comes from tracing one of the other paths. This is not like as trivial as just how do you break up if statements normally. Like, this is not as trivial as the normal thing is. Let me think. And the problem is that there's like usually even more wrapper logic in here. Ugh. It's just so bad. It's so bad. Like, this only works if you duplicate a bunch of logic for these. Modeling it like a state machine help? No. Let's look at what's in here. So this train forward calls gets graphed, for example, right now, right? Uh, the only other thing I could see to do, I'd have to change the whole way I capture graphs. So, the way that you delete this layer, you have to. The problem I think is the fact that we have this additional layer that's for graph capture, basically, right? Like this function exists. Why does this function exist? It doesn't exist for any reason other than so that I can capture it in a graph. There's not really an easy way to do it otherwise, though. You need to warm it up and shit, no? That's like crazy obnoxious. What's this warming up do? It's pretty tough to figure out a better way to do this. Freaking CUDA graphs, man. much does this buy us? It does buy us quite a lot, doesn't it? Use everything yourself. That is eventually what's going to happen. Okay. Right here, right? Train, select, and copy. This is a judgment call, but in my view, the frickin' code is too deeply nested. I think this is the right call. It's just way too deeply nested. This would get us back to still going to be sort of annoying. Mm. It will save quite a bit, I suppose. We're going to try this. I don't know whether I will like this more. Sets it back to the default stream is okay. This actually does let you amortize the capture iterations as well, which is nice. That's probably worth doing it alone, right? Still fast, right? Yep. Hmm. Fused rollout coup de graph. Hello, welcome. Plus side, this gets rid of all this janky graphing logic. I suppose we could break things potentially here. Fused rollout Qtograph. I don't know, this is fine. What do you look for in a good environment? Can you describe why 2048 was surprisingly useful? Because it's a very fast env that's easy to understand what's going on, and we were all surprised to see that it was actually quite difficult and it scaled very well with compute. So this now gives us a pretty solid benchmark for even reasonably large runs, where we can see okay, before we solve this thing in an hour with 10 billion steps, and in the new update, after changing the architecture and rerunning our new sweeps, now we solve it in 5 billion in half the time or whatever. So just the fact that it's actually a reasonably difficult task that is fast and that scales well. I mean, it's also not like artificial difficulty in some sense, right? We know that it has a reasonable encoding. We know that it's not just trying to understand pixels from scratch. It's just a straight exploration problem. If Puffer solves it instantly, would that be a waste of time? I mean, it could be a cool environment, right? It could be cool that Puffer solves it instantly. For instance, I think most of the bosses in RuneScape, which are very, very difficult for even experienced players to learn, I'm pretty sure Puffer would just one-shot them in a minute. It would be a really cool demo. It wouldn't be a super useful research environment, but it would be a really cool demo and a nice sanity check, I suppose. But definitely, yeah, overall, environments that have meaningful difficulty, and you do need to make sure it's actually meaningful difficulty, right? Um, those are pretty good. An example of a very bad environment would be you write get the password. You write the password is whatever uh, in pixels, and then you have the environment have to enter the passcode. That's a really stupid environment, right? It's really easy for people. It's really dumb for the agent. Well, a lot of the RL environments out there are actually just that in disguise. So there's some stipulations, but another good sign is relatively fast environments where progress is still indicative of performance overall. We do a ton of our basic experiments on Breakout, and Breakout seems to be the minimum complexity environment for which usually if stuff is better on Breakout, it's generally better everywhere. Not perfectly consistent, but pretty consistently. See if this still runs. Aborted. Lovely. This might be the environment thing, unfortunately. The end of GPU buffers. I see. Stream A captures with this. You probably just have to synchronize on capture. We can definitely mess with that though. Wait, what? Yeah, this is not how, oh yeah, this is fine actually. Isn't it? Yes. But wait, we do synchronize. That's weird. Oh, well, they're going concurrently. That's the problem, right? That's gotta be the problem. They're going concurrently. Yeah, that's moderately annoying. I mean, I'll be right back. Why is it just chilling here for like 5 minutes? Let me see if I can think about this. So we launch. Mm, capture mode relaxed. Drop pool sharing entirely. Each graph gets its own private pool. How about no? Yeah, how about no? Why are simpler M's still useful? They're faster. Neural MMO takes currently the best run we have takes 3 days on 6 GPUs, and we'd like to run 1,000 experiment sweep over it, but that's kind of tough. What is this? Net callback wrapper. Huh? Wait. Rollouts. How does this make any sense? Static vec OMP step. We do have another out to this, but it will slow the first few iterations down. If you had a lot more GPUs, then only complex M's would be useful. Not exactly, because scaling is also not free, right? Like, when stuff is slow, it also means you need heavier infrastructure in order to run the number of experiments you want. And heavier infrastructure is more prone to being buggy and screwy. So, like, it is very, very worth it to just put in the effort to make everything fast and simple. It's like really provides you the highest confidence and easiest way to reason about stuff. It would probably shift the top end of research, right, towards the more complex ends. But like, you don't really want to be running all of your experiments on a bunch of hardware taking a bunch of time. Like, ideally, what you want to do is you want to run really fast experiments that are strongly indicative of performance on harder ends. It used to be an RL that like you would have to do all your experiments on the target end because otherwise you'd run your experiments on whatever and then nothing would ever work on the other end that you wanted to get to work on. At some point, Puffer just got good enough that that stopped being a problem. Yeah. Is it because we're using the same stream? Are we using the same stream? We probably are, right? Wait, we shouldn't be, right? Capture begin. Oh, wait, isn't that... Wait. CUDA per buffer pools. I think that one is okay. Might be a memory, it might be more memory, I don't know. I mean, this whole way that we're graphing this is kind of ridiculous anyways. Really? What the heck would this even be? Maybe we have to wait for the M's to be ready. Sorry for the questions, you're good. I wouldn't be streaming if I didn't want to, answer stuff from the chat. If I sound irritated, I'm irritated at this thing. I'm trying to think, what do we do about this? It's super annoying. Because we need these streams before we can do anything. A lot of cleanup required. Yeah, this is also like evil, so. $12 to go until 5,000. Folks, please start PufferLib on GitHub. 12 stars to go until 5,000. I think that this is going to be irritating fighting with these graph captures, but if we get this to work, it should pretty dramatically simplify. It should dramatically simplify this file, I would think. Like, there's still a whole bunch of other crap to deal with in here. Okay, all this stuff is going to get pasted in place now, so that's chill. Well, I think I actually have, I've got a way to do it. It's just going to be a little bit slower for the first epoch. Actually, this is not even going to be that bad because you don't need it for the warm-up hitters, right? Yeah, this will work. I think so, at least. So if we do them sequentially. Okay, so if we do this sequentially, then that's a lot of the jank gone. We still have way too much freaking code in here. But that's like all of this. Yep, so that goes there. It didn't actually update it to call the right function. Which will be at... Okay, I see why it failed to do that. It's still easy though. Yeah. Okay. I think that this can actually be set to equals equals. And I think that that's the trick is we're going to be able to set that to equals equals, so it's only one epoch that's slower. Is this slower? I think this is slower. That would not be good. Oh wait, we are training with the one buffer. Alright, we're good. That's within noise. Okay. And I think we shouldn't even need cap mode anymore, right? Oh yeah, that's faster. That's where our speed went. Good. This is torch. Nice. Uh-oh. Are we worse now? Hmm. Hmm. Let's make sure we're stable. That seems odd. and stuff for core RL. I'd say most of the people around do ends. The core RL you need to have more low level background. Because it trains with one buffer, so there's definitely a diff, right? Yeah, you can see it there. It's definitely broken with this. Let's try this. TUI is beautiful. This? Thank you. I spend a little bit of time on it. It's just from it's built with Rich, so it's not in the C++, unfortunately. That Claude code are terrible. They are terrible, Alan. Yeah, shit, this is broken. I didn't catch it. Yeah, see, this one is correct. I'm gonna try this. Graphs are definitely screwing with each other now. Okay, so one buffer trains, right? Of course, one buffer trains. Nope. How would this be? I mean, they're doing something at the same time as each other. Anybody have any ideas? We've got multiple threads, like CPU threads, that are running multiple buffers. This should be doing them parallel, though. And then capturing when synchronization in between. Kind of weird. Let's go look at what this is going to be. Like, I think that this is worth it if we figure this out. Device sync. Something's not syncing. So the reason this is going to be so good is we're going to basically just be able to ignore all this garbage, right? We're going to be able to have this code get inlined. So we're not going to need like more and more functions. So much work to get this good, but I think it'll be worth. Yeah, this will end up putting yeah, this will be worth. Only one graph at a time. Multiple buffers replay concurrently on the shared pool. There's no concurrent replay, so it works. Only one graph at a time for a shared pool. Actually, did we do all the captures on the same pool? Let me look. Looking to build a more complex end that isn't trivial and I could PR. I mean, there are lots of them. Generally, you want an interesting problem that you have some expectation that, there'll be scalable difficulty to it. To give you an example, one of the recent ones that somebody did, Tim started building Sokoban, and I look at it and go, oh, actually, wow, that's a perfect environment. I don't know why I didn't think of that before, right? Pools. Where's this? Come on. Multiple replay buffers. Multiple buffers replay concurrently on the shared pool. That does seem likely. So, I mean, we can test this pretty easily just by stashing and just trying to train with like 20 buffers, 8 buffers or whatever. That would suck though, because that would be a perf hit. Could a doc say 1 graph at a time for a shared pool? Which would make sense. Did we just get lucky? That would seem pretty unlikely. Wait, we did find num buffers equals 1 in, oh. I could have actually messed that up. Yeah, I could have messed that up, couldn't I have? That would be a bad bug. Huh. And then that would account for variance, wouldn't it? Well, if that was the bug, then it's amazing that it was working at all. I hope that's not it, sincerely. We will see in a moment. I think I'd be pretty surprised, though. The heck? When graphs from the same pool execute concurrently, their private allocations can alias. GPU serialization. Okay, hang on. Be very careful. Get staff. Build. place force. Okay. Yeah, that's 16 mil SPS, my guy. That's stable. That's a 3-second solve as well. Okay. Well, the good news is we do not need, we don't need this. It's some bug. We'll figure it out. And we also have, that's a 3-second solve. So we are absolutely going to be able to solve breakout even faster than we have. We'll have a very, very nice speedrun result. I have no idea why this is the case, though. It's gotta just be something due to, like, creating the other streams. Should be synced, though. Model architecture ever change? I mostly see the same in-brew stuff. Well, that's a brand new architecture in 4.0, so yeah. We used LSTMs in Puffer 1, 2, and 3. So this is like a brand new architecture that we've been working on the last couple months to get into here stable and fast. Aside from that, yeah, only have seen the 4.0. Yeah, so, I mean, that's going to be the base of the architecture for everything in 4.0. You can add your own in. It's going to be swappable. But it seems pretty darn good to us. You can add in custom encoders and decoders. Most of the time, you don't need a custom decoder. I think a few M's are going to want custom encoders. It's mostly if they have like, weird observation shapes or stuff needs to get one-hotted or stuff like that. Which decoding part? Decode just means it's not language, right? Decode here just means map hidden state to actions, actions and value. I'm trying to think what would be the difference here. Like the network shouldn't be getting called until everything else is synchronized in the sequential mode. Really obnoxious. It's gonna be so nice when we eventually just drop Torch and we don't have to do this anymore. Just like no CUDA graphing, 15 mil per second training plus. Spend a lot of time in search space for kernels. Tiny and using their beam stuff. And project. So I messed with TinyGrad a lot. I liked what they were doing. Their kernels were slow. And they're not human readable at all. And they're also for a specific size only. Like it's a hard code to do a specific size. So I don't see how we're supposed to use them easily. I was going to try to pull some kernels out. And like I spent a little bit of time on it. And I just couldn't find like a nice way to do it. Like presumably, yeah, we can make it a lot faster. When do your tensor shapes change? I assume that's what you mean by size. When you run with a different hidden dimension or different obs dim for different n's, right? I mean, we'll run, the goal here is we're going to be running sweeps of 1,000 experiments, and the sweeps include the number of layers, the hidden dimension, right? You search during the runtime init for a given size, config and size. Yeah, but like, how on earth do I do it with their stuff, right? Like, it would have to be, it would have to, every time you run, at least for all possible sizes, potentially if like all new experiments, it would have to go run the slow beam search for that. And then it's going to generate a completely non-human readable kernel that's for one specific size. That doesn't seem particularly good. I tried, they do have kernels that are for variable size. They're still completely non-human readable, and they were very slow when I tried. Search happens as part of the runtime. Is it? It's way too long. Oh yeah, the kernel search. The kernel search is gonna take like 10 times as long as the entire training takes for our test ends. For our bigger M's maybe, but it's still so freaking heavy and clunky. And I honestly, I just hate the idea of having kernels not be human readable. Yeah. I mean, if you look at our kernel code, it's like, it's going to be so nice and easy, and we're going to be able to build so much stuff on that. Like, that's pretty much the only thing I'm actually happy with at this point, is having these, like, nice, fast, simple kernels. Not doing any search, man-made. Yeah, we have not done any kernel search at all yet, and we're already at like 14 plus millisteps per second. So, I mean, this is what happens when you overly abstract shit, right? Like, you just completely lose sight of the problem. Most of the kernels are not that complicated. A couple of them are a little iffy, but most of them are just not that complicated, and like, apparently nobody bothered to check baseline perf on any of this stuff. How good is 14 mil? So, okay, for context, PufferLib was state of the art in 3.0 with 3 to 5 million steps per second training. Most libraries out there are training at 10,000 steps per second. There's some high perf ones at 100,000, and then there are like a couple that are kind of cheating and using dumb architectures and stuff that maybe get like hundreds of thousands up to maybe 1 million. So we were already state of the art by like 3 to 5x or more, and now we're up from that to 14 million with it's like a small model. It's only 200k params, but it has memory. It's a 4-layer min grew. It can solve a lot of the simpler RL problems in seconds and trains 14 million SPS without even going to ridiculously large batch sizes. Dumb architectures. It's not a dumb architecture. Oh, dumb arch. No, no, no. Like no memory. A lot of the a lot of the RL libraries that say that they're really fast, they're just using an MLP. No memory. It's really easy to optimize that crap. But like those models are just not useful. Yeah. What's an example of one of those libraries? Does this thing have LSTMs in it? This one might. Eh, Nope, there you go. Completely stupid model. Completely unreadable code. Look at this. 7-layer deep nested function defs. And only runs on completely trivial, look, yay, vectorized cart hole. Completely trivial Jacksons. And look, they're bragging here about having what's this? Minotaur, which is a really, really stupid simple breakout in 5 minutes. We have it now in 5 seconds. There you go. Stuff like this. What are you doing? High performance RL. 7 layers of functions. Yeah. This is why the Jax people are just batshit insane. Like, it's not even fast. It makes a total mess, and it prevents you from throwing it on, like, actually interesting problems. I don't think you can capture on the main thread, can you? Shoving compilers into... Yeah, exactly. Like, if you need to JIT your Python, you probably just shouldn't be using Python. I hate that we even have to graph. MLP imply no memory. It's another MLP. It doesn't work. Yeah, that just doesn't work. You need at least some sort of reasonable gating mechanism to make effective use of memory. There's pretty much no variation of just simple MLP that actually works. Mingru is pretty good though. Capture on the mainstream. Is this how we're gonna do it? What in the hell is this? Completely stupid. Yeah, these models are just not capable of reasoning. They really aren't. Does anybody understand what the hell's going on? So before, what I did is I pre-traced all of the rollout graphs before I created the environments. The environments have a couple of CUDA streams associated with them because they manage their own async copies. Now what I'm trying to do is I'm trying to just use the first few iters of learning as the warm-up, and then trace it after, like after a few epochs, which should be faster. The problem is that somehow wires are getting crossed and it's letting me trace, but it doesn't learn, like with multiple buffers when I do it this way. So if I do this with one buffer, it works, but if I try to trace with multiple buffers, it doesn't work. I tried like running the buffers serially, still doesn't work. No idea. CUDA graph's kind of evil. Let me use the restroom real quick and get another cup of tea. All right. What? How is this stupid thing still spinning? Let me try to figure this out. So, graph capture, stream management. CUDA stream. Begin capture. All operations pushed into the stream will not be executed, will instead be captured into a graph. Capture may not be initiated. Capture must end. Oh. But then you'd lose one iter. It's actually not great, is it? We can try this real quick. I don't think that's right. I think we've got outs though. I'm realizing that this graphing is also going to mess with our profiling, isn't it? No. No, we can make the profile start after graph capture. That's perfectly fine. That's not, yeah, that's a very minor thing to have to deal with. That's easy. Let me think. If this doesn't work, what do we do? Well, we only have two places that we have to do this at the moment. Nope, broken. Damn. Just as broken. Sad. Well, shit. It could be the train graph, I suppose. Completely broken. Lovely. Absolutely lovely. Could just do it this way. Coup de graph's incredibly obnoxious. Incredibly obnoxious, I gotta say. Do they have the poster? Where's the poster? I don't know where the poster is. Did I put it on the website? I don't think I remembered to, did I? Ooh, I found it. Oops. If this doesn't work, we're gonna have to figure out what the hell else, because I'm out of ideas after this. Yeah, torch and coup de grace is like completely evil. Nope, still completely broken. Lovely. And just to confirm, works fine with one buffer. Great. Well, this completely screws us. This completely screws us. Okay. Oh, lovely. We get to deal with the billing tax, the anthropic tax. Realistically, I should just bill this directly to Meta because this is Torch being a piece of shit is what this is. Like the reason I'm even having to do any of this is because Torch is a piece of shit. $100 anthropic tax. Lovely. This will definitely work at the very least. It's we don't get rid of the capture logic at the top, so we're gonna still have that jank, but we won't have to have like the super deep nested calls. So that's not bad. We'll do this. It's 4. I'll apply all this stuff. We'll see if we can get the PufferLib C++ implementation into a reasonable spot. That's a good goal for today. So we'll have done the models file and then the main PufferLib file today. And then we'll have saved modules and kernels are going to take additional work. What in the hell? Don't need this. Don't need this. Very good. I hate coding with language models. Oh. You get stupid. So if anybody is wondering, no, 4.6 is not magically capable of reasoning. It's not capable of much of anything. But I'm still stuck using it because this is undocumented hellhole mess of C++ garbage. I'm going to be so happy when we just have everything in plain CUDA, CUDA C, and I no longer have to do this. That's going to be great. Okay. Let's see if this is done correctly. This should be very, very easy to have working now, because the streams literally don't exist during capture. Really? You gotta be kidding me. Also, did they make the model like way slower? It used to be like way quicker um on pretty simple ops like this. Yeah, literally it would have been faster for me to do this. So why the fuck am I typing into the LLM? Ugh. this is just moving them. Cool, that's fine. Well, now it just doesn't train at all. What? And it's slower. No, it's not. Wait. Does it sometimes train? I could have sworn I just had it train with... Yeah, it trained right here. Okay. Reset. Actually... It's probably that, right? It did train once. So if it's unstable... Okay, the work this morning was still kind of okay. This is like just intellectual sewage, is what this is here. This is awful. Why the fuck is this in a lambda now? What the fuck? Why the hell? Like, ever would you do this? No. Just no. Works. Can clean it up right after this. Hmm? This should be stable. We shall see. How is this still not stable? Like, how? Huh? Go nuts. I'm absolutely gonna go nuts. This crap. I hate this. What? How is it this stupid? I don't understand. Keyboard? Oops. What'd I do? One sec. Widow V4 75%. What have you missed, Jess? Pain. Pain and suffering. I'm just so sick of this crap. Then you'll just remove torch. I'm trying. That would be lovely. I'm trying to like make this not be 6 layers of nested functions garbage. Because the fucking way that coup de graphs work is awful. Huh? It actually would have been faster for me to rewrite Torch at this point, which is the sad thing. And better. We'll do that in Puffer 6. Lesson learned. There's no such thing as necessary evil when it comes to software. It's just like you'll have to deal with the garbage forever if you don't just delete it. I'm just not having a good time with this at all today. Fuck. Just forgot to update this crap. If we at least get this to run, I can get this cleaned up quickly. Because like I know all the stupid shit that it did, and I can very easily fix that. But we need the graph capture to actually work. Great. Works for one buffer. I think this is coup de grace off, isn't it? Nope, still doesn't work. Lovely. Well, I just don't even know how that's possible. It just must have fucked something. I don't know. Let's go look. Multi-threading, maybe. I mean, it's just like so sad that this is. I mean, you're gonna see by Puffer 6, I think, when we've just deleted Torch, you're gonna end up with like half the amount of code as if you were to have done it with Torch, and it's gonna be 10 times faster than Torch at that point. It's already like 6 or 7, I think. It's just it's so incredibly sad, the lie that all of modern software is, where it's like abstract more shit, abstract more shit. Don't go down to low level. That's scary. Just deal with the machinations of imbeciles that come up with stupid abstractions that don't fucking work. Drives me insane, man. How many hundred hours of my 29th year of life am I gonna have to waste dealing with Torch's horseshit? Torch doing any heavy lifting? We'll have to replace their auto grad, but that's nowhere near as hard as you would think. Like, you literally don't need auto grad. The entire concept of auto grad is just like, ugh. You don't even need it. Wait, who did device synchronize? I don't do that. Does this screw this up? It totally screwed this up. AD is pretty useful. Really? I've spent several hundred hours learning how useless it is. Heaven forbid you have to call your own dot backward function. course, autodiff seems super useful when you have a massive graph because every single op is its own kernel that you can't even find anywhere in the code base. "30-minute compilation." Yeah, that won't take long. Why can't we just have a neural net library by NVIDIA? Why can't we just have that? That would be great. You know, we could have a library that's just kernels.cu that has all the kernels you need. That'd be great. You've got to be shitting me. Okay, how the fuck does this still not work? QDNN, not open source, right? And yeah, the QDNN kernels actually work. If only we could see them and like mix and match them. OSS kernels, that's awesome. If we get open source NVIDIA, that'd be just great. Hi, what are you doing today? Suffering. Attempting to get coup de graphs. I'm trying to change the way that we do coup de graphs so that it doesn't hide so much bloody code behind like several functions. And it's just not a good time. It's just not a good time. I'm honestly wondering if we just have to go back to the if we have to just go back to the previous version. How much stuff do I change on here? I think I changed a whole bunch of crap here. Yeah, I changed a lot of crap. Well, this is just going to take me an hour because, like, this thing takes forever. And now this is the only way I'm going to have to be able to get it back into working state. And then from there, just have to try it again, I suppose. I mean, this is just so irritating. I could try that. Every time I try Sonnet and it doesn't work, though, the chat is immediately like, oh, well, you're using Sonnet, even though this thing is clearly stupid. Ooh, that might be it. Hang on, that one might be it. If it just fucked up the port. Is that it? Um, buffers. 8. That was it. It literally just fucked up the port. Good job. Great use of time. Stupid. So stupid. Yeah, I'm going for martinis after this shit. Like, fuck. Better than an hour lost? Jess, I've been live for 8 hours and 15 minutes. This in particular, I've been doing at least the last 2 hours. I like working long hours, but not when it's complete and utter horseshit. Okay. I'm gonna go through and I'm gonna do it a slightly different way. I'm gonna go through and I'm gonna use the CC tags thing that I do, and we're gonna unfuck the code. All right, ready? Hypers.cutographs. Long hours, yeah. I mean, realistically, like these aren't even long hours for me. I've kind of just done like I've done enough long hours when I was younger that this is kind of just whatever. But man, like being fucked with for hours on end is not fun. all of this, for reference, was to remove one layer of extra functions. Yeah. That's how much I care about having this thing refactored nicely. Because I know when you go look at a new piece of code and you're trying to find, like, PPO loss logic, and you have to click through 4 layers of functions to find it, the code base is shit. That's why I spend so long not doing that. Okay, this is the easy thing, yes? Easy now. Very easy. We're gonna go get that comment as well. It's inlined. Oops. It's inlined. Yes. Backward. Oh, lovely. Scrolls me to the top for no reason. Good. It's funny when they say, "Oh, but like the Claude app, we wrote Claude code with Claude." Yeah, I can tell the app sucks. Keeps scrolling me up randomly and flickers randomly sometimes too. Yeah, why did it's just scrolled me all the way to the top? You see? Fuck. Yeah, choosing the same function's fine. Hope, hope we're good. Fuck's sake, man. Fine, we'll do this. Stupid, but that'll work. I don't know why it's like this. Drive me insane. If this runs, though, if this trains at least, this will be very close, and like I can actually go look and figure out a lot of the cleanup, I think, from here. If this broke training, I'm gonna lose my shit. Okay. We are good. Also, we have 3-second solves now. Yep, that's just 16 million step per second training. Very cool. I'll be back. We're actually going to need to get a harder benchmark because it's getting to the point where breakout gets solved so fast that we don't even get to spin up to full training speed before we solve it. Okay, we got 977 lines of code here. But we have less garbage. I believe we have less garbage. So net callback wrapper now. Neural MMO benchmark, too slow. Or rather too hard. Like, we need a 30-second benchmark, basically. We need a new 30-second benchmark. It's got to be like a super fast end that's hard enough that it takes us 30 seconds to solve. Now, we can find something in here, probably. Ideally, it's something with relatively short epochs as well, because that also messes up scoring. Like, epochs, at most like 1,000 steps would be good. Epochs, I mean rollouts. 1,000 steps would be good. Now, we'll figure something. I think most of the M's on here are going to be solved sub 10 seconds with Puffer 4. Sparse maze? Yeah, we might end up doing that. We'll see. The thing is, there are a lot of different configurations of sparse maze. It's not just like one task cleanly. And also, I don't think sparse maze is, it's like a good benchmark for some types of stuff, but not for everything. Let's make a quick commit before I screw something up. I don't want to lose this. What time is it? It's 5? I got about an hour before I gotta go to dinner. It's about all the brain power I've got left for today as well. Let me see if there's any more high-level change that I think is required before we start doing the fine-grained stuff. It seems like this is still way too long to me. If else pattern is a little weird. $8 without interruption. I mean, 8 is one normal workday. And I do more than that. It's like a week Western work day. It's got sample actions on here. But actually, this is pretty nice like this. I think we just do fine-grained on that and we're good. Same here. Train impl. I don't like how we have this if else because of the profile. No, that's actually kind of okay, I think. Okay, so this is only 590 lines in, and we had some stuff at the top. So 500 lines for all this, and then we have this massive ass create function, right? That goes in ocean. This is B float, buffers, states, graphs, restore weight, and streams, tensor, close, like jank. Okay. I think we are actually kind of ready for the fine-grained. This might have to move. quarks. Don't like this either. Do we want this inlined actually? No, I think we'll actually leave this for testing. I'm trying to think if I want to leave these just C-style nice like this. I probably do, right? On a hypers. Oh, you do need this, don't you? Yeah, it's annoying. But wait, does this get used? Do you actually use this? Capturing. Compute train loss. Do you see it in here? I don't see it in here. No, I don't see it in here at all. Apparently this is in here. Apparently this is in here. Advantage, mean, advantage, variance. But compute. Var mean of advantages. And compute train loss. Okay. How do you get focused on this one project and not get distracted? Because it's all just fucking noise. It doesn't matter. I mean, do you really care about the stupid status games people are playing at the expense of like real technological progress? Like most of the AI shit around is like really not serious anything. It's all just hype and grift. It's not why I got into AI. AI used to be like a way more serious technical field. Of course, it also didn't work, but like I basically know that if I just keep doing this for the next year or two, I will have this entire area of science stable, mature, broadly applied, like tremendous, tremendous amount of progress. Did I already get down to here? I didn't think I did. Hang on. Yeah, no, we're still up here. Oh, I think we're actually going to be able to go full deterministic as well, which would be cool. Says torch shit, right? Yeah. What on earth is this crap? We'll mess with this one after. Mess with this for now. Capture begin. Okay, we're gonna have to figure out all this stuff. This like selective, narrow, whatever the hell. This is kind of ubiquitous. I don't have a good way to deal with that yet, though. Load current epoch over total epochs. Those will get deleted. Oh, I see. Hmm. Don't like that. Wait, why is this in massive ass signature on compute train loss? Don't ever inline if statements like that. Unfortunately, yes. Not happy about it. This will go away. Coup de graphs. It's pretty gross. I don't want to touch that though, that's fiddly. And that's fiddly as well. And then this thing here, I actually don't know what it is needed, and that's like horribly unstable, so there. I hate that I have to use freaking Claude so much for this cleanup, but holy hell, this is just so garbage, garbage, garbage. And I want this to not be garbage, garbage, garbage. I think I'm just not going to release this until I naturally find myself not wanting to use Claude on the code. Because if I want to use Claude on the code, it's because the code sucks. I don't want to use frickin' Claude when I'm doing my own ends. It's super easy. It's only when I'm dealing with a bunch of bullshit. I can't wait for them to be embodied so I can body one. uh, that's hilarious. You guys basically got the whole list backwards. That's impressive. He doesn't know what a greater than sign means. What do we do? Right. And then in the meantime, we have a problem we can think about. We have several little refactor problems we can think about, right? Instead of just sitting here being lazy. The main one I wanted to figure out, these narrow ops, this select narrow copy pattern, it's kind of crap, right? Like, look at this network call here. This function is actually very simple, but it looks very complicated because the syntax is a mess, right? Dot select dot narrow. Oops. Torch indexing. What the heck is this? Oh, get rid of this. Slices are interesting. I don't know if that's gonna be, it's probably got some annoying overhead or some bullshit knowing Torch. There's dot slice, dim, start, start plus length. Keep the dimension. Oh, I have 13 notifications. Well, the notifications are like backed up today. Yeah, it's funny. It's like the 10-minute long dips are like an inside joke. Look, I gotta wait. I gotta walk all the way downstairs. I gotta wait for water to boil. I gotta make my tea. I gotta get upstairs. All right. You try streaming for friggin' 9 hours without having to get up to do stuff. Actually, don't. That's kind of terrible for you. At least I gotta go up and down the stairs a few times. Making and delivering tea. What logos? Okay, this is a little annoying. It's gonna take another couple passes, but it's a lot of cleanup. Mm-hmm. Selection. Okay, so there's three things here. Out of curiosity, 900 lines. Okay. Why are we deleting my profiling functions? Fine, we'll just do that. Mm-hmm. That goes there. 870 lines. 847 lines. And then this last one will be slightly irritating, I would think. So we're removing bf16 as a flag from the settings because it's now compile time, which actually makes the code a little bit simpler. That's fine. It has to use the torch D types for this. That's fine. Device Kikuta. Device. Kuta. Q. And we get to remove one hyper. This D type becomes precision D type. Probably renamed to precision T. Is fine. There is a little bit of conditional logic. No big deal. Trips a couple things. I think that works. We delete bf16. And 845 lines. Seed 1. Oh, lovely. Lovely, lovely. Horrifying internal compile error. Lovely. My favorite. Train impl. Invalid use. Okay, so just forgot this. Cool. Three seconds. Not bad, right? Yeah, that's a 3 second right there. Like the reason I'm doing this is because I think we're basically there. Like I think we basically have it to here. There's probably like just one or two small sources of randomness. I suppose the environments, since the environments are threaded, it could be a little weird. Oh, it's gonna return like the native path. We don't need the native path to be deterministic, just the kernel's path. Fully deterministic training backend would be so nice. Hmm. There is probably, my guess would be threaded. Is there thread specific RNG? I see. And R. Okay. We can do this. It's pretty cool. It's probably the end. Um, let's not do it this way. That's so ass. Okay, we'll just do this one. This should be easy. Two-bit RNG is fine. It's easy. You see what I'm trying to do, right? Like, oh, I should make a nice commit on, I should make a quick commit on this. Yeah, let's do that first. What? I said just. Stupid thing. It just has one rand call on reset, I believe. Makes it a really nice, nice end for testing. That's what we want. $830, 1461. Still not deterministic. Okay, so use the OMP pulse is no good. This is now going to do multinomial is the thing. Whoops. That's interesting. We broke non-kernel path apparently. dude. I'm pretty happy with the progress overall, even though it was a pain in the ass for several hours. I mean, there's still some stuff like this where this is annoying. Obviously, the bottom of this file is still a mess. Better though. Oops. See if this does it. Yes, it works. Very nice. No custom kernels, 8 mil. Funny enough, though, it doesn't train because of bfloat with torch kernels. Isn't that funny? That doesn't make any sense anyways, though. So let's just do this. Let's see how the training is from run to run. 854. Seems closer, maybe. No, it's still off. Other primitives are not. Okay, so this is fair. should be developed in Puffer 3. Yep. It's going to be very, very similar, Liberty. I gotta finish stream soon. I've been live almost 10 hours. Is this better? Seems better. I think this is probably unlikely to work, right? Yeah, we got the graph issue. It was awful. I mean, what do we think, folks? Like, is it worth adding uh, one additional thing to the Puffer API spec to improve RNG? Because we're not going to be able to get it full deterministic. Let's just see what the variance is with this. See, there's still plenty of variance. Oh, This is really good. I'm just seeing if we can get determinism out of the library. I mean, into the library. Oh wait, 829,382. No, it's not the same. Okay, it's still not deterministic. We'll play with it. I don't know if it's going to be a realistic thing to have, but it would be super nice if we could do it. I think it's probably not something we should do right now, though. I would say. So we'll leave this be. Uh, I gotta go get dinner. So thank you, folks, for tuning into the stream. Probably won't do a stream later unless I'm, for whatever reason, feel like super motivated to do another 2 hour stream after 10 hours of stream already. If you want to help me out for absolutely free, just feed the puffer a star on GitHub. It's like less than 20 stars off of 5K. It's rounding up. It'd be really, really awesome to hit 5,000 stars this weekend on the project. If you want to get involved with development, join the Discord. If you want more reinforcement learning content, follow me on X. This is where all of the educational articles are going to be, and all like the research stuff I produce from Puffer 4.0 will be on here. So thank you all, and have a nice weekend. I will be back streaming a little bit on Monday.